In chapter 1 we have new topic, irrationality of a number. In this topic we are given that root 2, root 3, root 5 are irrational or not. Further we are got that 2 plus root 3, root 3 plus root 5 are irrational or not. To check that. So to check that, first we will study the important result, that is, if p is a prime number, then prove that root p is irrational number. Now this result we will prove by contradiction method. So in contradiction method, if we want to prove root p is irrational, then we will assume that root p is rational number. Now root p is irrational number. Root p is rational number. So we know that the rational number can be written as a by b format. So root p equals to a by b, where b not equals to 0 and a and b are co-prime. That is means HCF of a and b is equals to 1. Now root p equals to a by b. So by squaring both the sides, p equals to a square by b square, means a square equals to p multiply b square. So a square equals to p multiply b square, that is means p divides a square. Now we know that p divides a square, then p divides a. So p divides a, that is means a equals to p multiply m. So a equals to p multiply m, we submit into the result a square equals to p into b square, and it will be p square into m square equals to p into b square, which we simplify, then b square equals to p multiply m square. So p divides b square. P divides b square, so p divides b. That is means p is the common factor of a and b, and it is none other than 1. So HCF of AB equals to p. But we have here taken condition that a and b are co-prime, so its HCF will be 1. So which is contradiction. With HCF of AB equals to 1, and so our assumption is wrong. So we can say that root p is irrational number. So here we have proved that p is prime number, then prove that root p is irrational number. Using this result, we can prove any sum of any prime number. Suppose we want to prove that root 2 is prime number, then p replaced by 2, then it becomes the root 2 is irrational number. So let's we prove that root 2 is irrational number. So again we go by contradiction method and let root 2 is rational number. So as per the definition of rational number, we can write root 2 equals to a by b, where at b not equals to 0 and a and b are co-prime, that is means HCF of ab equals to 1. So root 2 equals to a by b, squaring both the side, we get 2 equals to a square by b square, and so a square is equals to 2 multiply b square, that is means 2 is a factor of a square, that is means 2 divides a square. Now 2 divides a square and 2 divides a. So 2 divides a, that is means a equals to 2 multiply b. So value of a, submit in a square equals to 2 multiply b square, then it will be 4 into p square equals to 2 multiply b square. So 2 2's are simplified. So p square equals to 2 multiply p square. It shows that 2 divides b square, as 2 is a factor of b square, and so 2 also divides b. So 2 divides a, here we are writing, 2 divides b, and so a and b are other than 1, so HCF of ab equals to 2. But here we have said that a and b are co-prime, so its HCF is 1, which is contradiction. With HCF of AB equals to 1, and so whatever we have assumed that is false and given result is correct, and so we can say that root 2 is irrational number. Similarly, using the result, if p is prime number, root b is irrational number, we can prove that root 2, root 3, root 5, root 11, any number is irrational number. Now let us prove that 2 plus root 3 is irrational. So again we will go by contradiction method. So let 2 plus root 3 is rational. As 2 plus root 3 is rational, we can write it 2 plus root 3 equals to a by b. So 2 we take equals to the other side, from left side to right side, then root 3 equals to a by b minus 2. Is also a rational, and so root 3 equals to a minus 2b by b is a rational. But we know that as 3 is prime, root 3 is irrational. And so we have contradiction with that. Here we are writing root 3 is irrational, and here we know according to result 3 is prime, so root 3 is irrational, and so our assumption is wrong. So we have contradiction. And so whatever assumption is there, that is wrong, and so 2 plus root 3 is irrational. Let's we see another example. Prove that 5 minus root 2 is irrational. So again let 5 minus root 2 is rational. So 5 minus root 2 is rational, so we can write 5 minus root 2 is equals to a by b, where b not equals to 0 is rational. So we can write that root 2 equals to 5 minus a by b. That is means 5b minus a upon b is rational. But again we know that as 2 is prime, root 2 is irrational. So we are getting contradiction between two statements, and so we can say that our assumption is wrong, and so 5 minus root 2 is irrational. Let me prove root 2 plus root 3 is irrational. So let root 2 plus root 3 is rational. So we can write that root 2 plus root 3 equals to a by b, where b not equals to 0. So root 3 equals to a by b minus root 2. Now by squaring both the sides, root 3 square will be 3, and here a by b minus root 2 square. So by simplifying it will become 3 equals to a by b minus root 2 whole square will be a square by b square minus 2a by b into root 2 plus 2. And so we simplify it, and it will become 2 root 2 a by b equals to a square by b square plus 2 minus 3. So it will be 2 root 2 a by b equals to a square by b square minus 1. And so we can write that root 2 equals to b by 2a multiply a square by b square minus 1. This all as a root 2 plus root 3 we have taken as rational. This all procedure is a rational number. So this simplification is also a rational. So root 2 is rational, but we know that as 2 is prime, root 2 is irrational, and so we are contradiction with the two statements, and so whatever assumption is there, root 2 plus root 3 is irrational. Let we prove that 5 root 2 is irrational. So let 5 root 2 is rational. We assume. So 5 root 2 is rational. So as per rational definitions, 5 root 2 equals to a by b, where b not equals to 0. And so we can write that root 2 equals to a by 5b is also rational. But again we have as 2 is prime, root 2 is irrational. So we are getting contradiction with two statements, and so we say that our assumption is wrong, and so 5 root 2 is irrational.